In this video, I'm going to introduce the power rule, which is a rule used when we are trying to take the derivative of something. Alright, now before I actually get into the power rule here, I do want to make sure that you've got the background information here that the derivative of a constant is 0. Really, that's probably the very first thing that they show you or talk to you about before you introduce that power rule. Alright, so in example here, if I had y equals 6, alright, 6 is a constant, so I automatically know the derivative is going to be 0. So the derivative will be y prime equals 0. Alright, if you write it and using that prime notation, y prime, you're telling whoever's grading your paper, you've now taken the derivative and the derivative is 0. Alright, same thing here on this. If my function is f of x equals a negative 8, well, negative 8 is a constant. So basically the derivative is 0, so it's going to fall out there. So again, showing that you've taken the derivative, f prime of x equals 0. If you were working it out in a polynomial equation, basically it would drop out because you wouldn't want your plus zeros in there. Okay, now to take a look at the power rule here. Initially, this is a pretty simple derivative rule. Alright, d dx of x to the n power, so I'm taking the derivative of x to the n, alright, which means that I can take this exponent, multiply it by the coefficient in front of x, and then subtract 1 from the exponent. Okay, so very simple implementation things of this here. My original function is f of x equals x third, so my derivative f prime of x would be me taking the 3, multiplying it by the coefficient, which is 1, so 3 times 1 is 3, and then x raised to the, now I got to remember to subtract 1 from that exponent, so 3 minus 1 is 2, so 3x squared. Okay, on this one, I've got a function of f of x equals x to the 1/2, so when I take the derivative, alright, I'm going to pull that coefficient down in front. 1/2 times the coefficient 1 in front is going to give me a 1/2. And then x to the, okay, now you got to subtract 1, so some of you are going to be better at that than others. 1/2 minus 1, alright, well that'd be negative 2 over 2. 1/2 minus 2 over 2, so a negative 1/2. Alright, now you don't want to leave your answer with negative exponents, so I would take this x to the 1/2 and move it to the bottom and make it positive. So I'd have 1 over 2x raised to the positive 1/2. Alright, and then if your teacher doesn't want fractional exponents like that, then we could turn that into radical notation, like 1 over 2 square root of x. Alright, pretty much both of those are equivalent answers, just different ways to write it. Okay, now on this one, alright, f of x equals 1 over x squared doesn't look like it fits our power rule. Okay, so these two were straightforward applications of the power rule. Could be that you're going to have to manipulate your equations just a little bit before you can apply it. Think laws of exponents. If I move this to the top, and it's going to turn it negative, so in other words, then my f of x would be x to the negative 2, because it's still f of x, because all I did was move it to the top and change it. Now when I'm ready to take the derivative, f prime of x, now I can do it on this because I have a base raised to an exponent, so negative 2 times the coefficient in front, so negative 2 x raised to the, now think subtract 1, negative 2 minus 1 would give me a negative 3, and then there again you're probably not going to want to have negative exponents, so you're going to leave the negative 2 in the top and write it x to the third. Okay, so there's 3 very quick examples with it, 2 direct applications of the power rule, and then a third one there where you're going to have to see some manipulations. Now I would like to do 3 more manipulations and things that you might see with this power rule. Okay, so let's change up our function. Instead of always calling it f of x, let's go g of x equals the cube root of x. Alright, so here again I don't really have a power, but if I rewrite this into a rational exponent, alright, and there's a little 1 right there, then really I have an x to the 1/3 power. Now as soon as I do that, now I can implement the derivative rule of the power rule. Show that you are taking the derivative by going g prime of x. Alright, 1/3 times the 1 in front. And then here again, 1/3 minus 1, so I'd be minusing 3 over 3, which is going to give me a negative 2/3. You don't want negative exponents, move it to the bottom. So 1 over 3 x to the 2/3, and then if your teacher doesn't like rational exponents like that, then technically you could change that to 1 over 3 cube root of x squared. Both of those being equivalent answers there. Alright, on this example we've got y equals 4x squared over 5. Well, written like this, and you'll see it this way in textbooks and stuff, you really, you should recognize that 4/5 is the coefficient, but if you can't, pull it out and write it like this, 4/5 x squared. Alright, then it might make it way more clear there on what you're going to be doing here. I'm going to pull the 2 down and multiply it by 4/5. Alright, so when I do that, I'm taking my derivative. So y prime, 2 times 4 over 5 is going to be 8/5. And then subtract 1 from my exponent. 2 minus 1 is going to give me a first power there. Alright, and then in this last one, let's suppose it's a 1 over something. Okay, definitely power rule is not happening here. So probably a lot of algebra steps before I go to take the derivative. Okay, so let's first rewrite this as an exponent. So I still have f of x, because I'm just going to be manipulating my original equation. So how about 1 over 2x to the 2/3. Alright, now I want to be able to implement power rule, so let's move the base with its exponent up to the top. And I'm going to rewrite this out in front here. So I'm going to go 1/2 and then x to the negative 2/3. Okay, now I think I'm finally ready to take the derivative because I've got power rule implemented here. So f prime of x. Alright, so 1/2 times a negative 2/3. Hopefully you can do that in your head. That'll be a negative 1/3. And then x raised to the, I've got to subtract 1, but really I'm subtracting 3 over 3. So a negative 5/3. Alright, now I don't want to leave that as a negative exponent. So negative 1 over 3x to the 5/3. And then there again, if your teacher doesn't want rational exponents, then you could rewrite it as negative 1 over 3 times the cube root of x to the 5th power. Okay, so basically there are just maybe 6 examples of that power rule. Power rule in and of itself is a really simple rule, and usually the very first one you're taught in differentiation when you start doing those derivatives. So definitely thanks for watching, and be sure and subscribe to the channel. Thanks.